Okay, for notes 1.8, there's quite a bit of data here. So what we're going to do is we're going to make box plots. Back in Algebra 1, you know them as box and whisker. We're just going to call them box plots. We're going to, from those, find the interquartile range. We're going to talk about how do we identify something as an outlier by using this rule. And then we're going to compare distributions in box plots as well. Okay, so let's take Barry Bonds. Barry Bonds, very good home run hitter. Turns out he was on steroids, but anyway, we're going to take his data, and here's his 21 seasons in the Major League Baseball, from lowest number of home runs that he hit all the way up to the highest number of home runs that he hit. So when you think about quartiles, I think I first start out asking my kids this. So say you have a loaf of bread. Okay, there's a nice piece of bread there. So how would you cut it into fourths? Okay, so if you and your three friends, you want to make it even so everyone gets the same amount. So I think a lot of people would go and they would cut it in half first, and then they would cut that part in half, and then they cut that part in half, and then you get 4 equal parts there. That's basically what we're going to do with this data here. Okay, so we want to start by making a number line. So our lowest number is 16. So let's start at, 15, and we have to go all the way up to 70. So I'm going to go by 5s. Okay, so we start with a consistent number line. Don't skip numbers, because we want to be able to see how spread out it is. Okay, so our lowest number is 16. So right here is 16. Our highest number is 73, which would be about right here. So what we have here, this line represents the range. Okay, so we can take 73 minus 16 there, and that gives us what our range is. Okay, now what we want to do with this data is now find our median. So our median, remember, is the middle number. So I'm going to start marking them off. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1, 2. Looks like our median is right there at 34. So 34, I'm going to put a little line here. That's our median. Okay, half our data is below, half our data is above. And then we want to take, just like that bread, okay, we cut it in half. Now we want to take the lower half and cut it in half. So take these lower numbers and cut it in half. Now, if it's exactly on this number, we do not use that number. If it was between these two numbers, I would use it, okay? But here I'm going to count 1, 2, 3, 4, 1, 2, 3, 4. Okay, now our lower quartile, we'll call this quartile 1, is between 25 and 26. So if you remember, what we do for that is we add them together and divide by 2. So our lower quartile is 25.5. So right here, 25.5 is my lower quartile. Okay, we want to do the same thing to our upper numbers now. Cross them out until we find the, it's 1, 2, 3, 4, 1, 2, 3, 4. It's going to be between these two. This is our third quartile. Okay, we had our first quarter, our second quarter, and our third quarter. Okay, third quartile is at 45 plus 45 divided by 2 gives you 45. And then you can draw your box there and you have your box plot. Okay. So when they ask for the 5-number summary, what they want is your minimum, which is 16, your maximum, which is 73, your quartile 1, which was 25.5, your median, which was 34, your quartile 3, which was 45. This is called the 5-number summary. Okay, those 5 numbers there, they go into creating your box plot. Okay, now, what we want to do now is decide, was 73 an outlier? So that year when he, if you know baseball, he and Sammy Sosa went back and forth with the record. They were kept hitting. They were both on steroids, but was 73 a very unusual year for him compared to all the rest? Okay, that's what we want to find. So this is how we find the outlier. We have to find the inner quartile range. Okay, so our quartiles were 45 and 25.5. So the range between those two, just like when we found the range, we subtracted that and that. The inner quartile range, we're going to subtract that and that. So we just take 45 minus 25.5. Okay, which gives you, yeah, I can just do that in my head. Be 19.5 is our inner quartile range. Okay, now to decide if this is an outlier, we're going to take our inner quartile range and multiply it by 1.5. Okay, so I'm grabbing my calculator here. Multiplying it by 1.5 gives me 29.25. So what I'm going to do is I'm going to take my quartile 1 and our quartile 3. Okay, so looking at this quartile, if something is more than 29.25 above this number, so 45 plus 29.25, is equal to 74.25. If something is above this number, then it is an outlier. 73 is not above that number, therefore 73 is not an outlier. Even though it's way out there compared to the other numbers, it is not an outlier. If we want to find an outlier below, we take the 25.5 and we subtract the 29.25. So we take our first quartile minus the inner quartile range, okay? And that gives us an answer of negative 3.75. And obviously there are no home runs that are below negative 3.75. So no outlier below, and there's no outlier above. Okay? So we talked about how to make a box plot, talked about how to find the inner quartile range, the distance from there to there, subtract the two. We talked about how to identify an outlier. Take your inner quartile range, multiply it by 1.5. Add it and subtract it from your two quartiles, and anything outside of those numbers would be an outlier. Okay? I want to talk about this as well. If data is symmetrical, we want to use mean and standard deviation when we describe it. If it has a skew, the other day we talked about the mean would really be affected, so we use the median. And then for the spread, we're going to use the inner quartile range. Okay? So this inner quartile range would be in SOX, what we would say for the spread. Okay? Since it's skewed data. Okay? The other thing two other things we want to think about here. If we look at this data right here, this data, here's the box and whisker for this. From a box and whisker, can you tell me a lot about that shape? So I can't really see, from a box and whisker, I can't see that there's two peaks with nothing really in the middle. That's the downfall of the box and whisker, or the box plot. You can't always see everything, all the shape within it. Okay. Last thing we're going to look at here is comparing these two distributions. Want to compare the texting habits of males and females, so how many texts were sent in over a 2-day period. So we have our males and our females. Okay, we have the box and whiskers for those. By the way, if something is I didn't show you this on the last one, but if something is an outlier, what they do is they don't usually extend this out all the way. We just put dots there for the outliers. This would be the one that's in the last one that's inside. If you extend it all the way out, I'm okay with that too when you make yours. Okay? So by looking at this, one really, really good way, remember how we said if something is skewed, that if it's like skewed to the right, notice that we have more data out here to the right. If it's skewed to the right, remember how the mean is really affected by that and drawn up? So here we can see the mean versus the median. Mean's a lot bigger for both of them. So we can see that they're both skewed to the right. Okay. The center, males have a median at 28. Females have a median at 107. So we can say the females have a larger center median than the males. Variability. Okay, so since we have that skew, we're not going to talk about standard deviation. We're going to talk about the interquartile range. So we can see here that the females are more spread out than the males, interquartile range. And outliers, if you take this, multiply by 1.5 and add it here, it's out here somewhere, so there's no outliers. Whereas here, there are 2 outliers that have been identified. Okay, that is section 1.8.